have to start right now. Just a couple words regarding the topic. So, okay, let's just gonna start. My name is Anton. Do you see my screen right now? Okay, that should be good. So, okay, we won't wait for everyone. We just have our time here, and we are on the committed. This is the platform. This is the set of events, especially for the engineering, the people, for the digital assurance domain, for the test professionals, for the testing experts, for those who contribute and create the quality. So we're gonna be focusing on such topics all over the way, and we're gonna start from the risk management. So risk management is the topic that is usually often being discussed lots of times on the different conferences, meetups, etc. But the problem is that in theory, it works fine. You know, in theory, everything is like, wow, cool. Look at that. I can do it by myself, but hey, here's the moment. So once you are trying to adopt it, to use it, here comes trouble, right? So the reason why this topic is in here is that we can discuss on how to not only know the theory, but also how to adopt it in real life. So we're going to discuss the examples. We're going to talk about how it can be changed depending on the way you work on your company or in your project. So usually this event is being planned as a workshop, but we'll see if we have enough time and people to participate in all the examples. But all the way, those are in this deck, so it will be shared later, and the recording of this meetup will be also present, so you can review all the time. So just a couple words about me. You can take a look at me without a beard and all this stuff before the quarantine. By the way, hope you are doing well during these tough times. But my name is Anton again, and I'm doing lots of QA stuff. I'm doing consulting, teaching, mentoring, and also responsible for the digital assurance in my company, in exactly the region, Central European region. And I'm usually busy with the pre-sales, with the advisories, with the new project ramp-ups, with the timeline, cost estimates, etc. So basically, with this topic, I'm pretty familiar because some clients are asking about this pretty often. So I'm going to share you not only the theory I have here, but also my experience to the point I am able to talk about that, right? So enough about me. Let's just take a look closely. It's some theory that we can start from. So what is the risk, right? We're going to talk about different kind of risks, and actually this topic can be applied to any risk, to product, project, people risk, anything. But I will be focusing more on the quality risk, on the product risk, because this is what usually QA is being working with. So risk, this is something that could result in any troubles that may appear, right? Why do we do testing? The testing we're doing because of possible defects that may come up in the after the release, right? So the problem is when we are coming closer to the risk, we're thinking about, well, I can predict only a little. I cannot predict everything, so this is useless, right? Okay, you may be right at this point, but the risk itself, this is something that could serve as a basis for the testing. Just imagine in this real world with the agile, with the Scrum, with the best practices around that, the requirements are changing pretty often, right? And in this case, you need to change your test cases. You need to change the documentation. You need to change everything. So you're spending a lot on maintaining these things. And at some point, you say, "Okay, I don't want that. I wouldn't create the detailed test cases anymore. I have a checklist, and that's it, because I don't want to maintain it." And now you're sacrificing the quality of your testing because of the changes. But you can put it to another way. Imagine you can have a solid basis for your tests. The risk may work as a basis for your test cases. You can ask, why? How this is possible? I will answer that every feature of the product is usually being sold to a customer. We're not buying the products because of their fancy look or something. Well, we might, but we don't buy those products because the products are. We buy the service, or we buy the opportunity that this particular software can open for me. So I'm buying the service that this product can do something for me. So I'm buying the feature. I'm paying for the outcome of this feature, right? And so it might be agile, Scrum, but the business value of the features usually remain constant, because product owners, product managers are usually thinking about what benefit they could bring to a customer. So usually the business value didn't change. The implementation way, the look and feel are changing, right? So if you're thinking about, okay, how this feature may not lead to the proper outcome, how it can be broken, how it can be changed the way people cannot use it. So if you think this way, this risk will be constant, your basis for the testing. So you're just thinking, okay, how I can broke it, how this might not work. And this basis you use for your tests, because this basis won't be changed. Risks are not changing. They have only their characteristics being changed. So, okay, let's start from the risk. There are two types of a risk we usually interacting with on work in real life, whatever. So the product risk is the risk directly related to the test object. So the product risk is something you could actually deal with. There are also the project risk, which is related to the management, control, resources, deadlines, etc. So we'll be focusing more on product risk than the project risks. You may ask me, well, how I can distinguish the product risk from project, right? How? There's one good way to do that is to ask yourself, is this risk can be removed, mitigated with some test or not? If it can be, then this is the product risk. So we're testing, we're mitigating the risk by test. If we cannot do that, this is the project risk. So if we go further, our usual work picture gonna change a little bit. So just imagine your regular sprint when you have some acceptance criteria list, and you don't know how this feature will be implemented. Like classic situation, right? So your developers at some point, they don't understand how the feature will be implemented completely at the very beginning. They will understand that during the development. This is what it happens. So at the beginning of the sprint, nobody knows how it will be implemented, usually, because nobody does the detailed requirements at the beginning due to ceremonies and rules. So we're gonna work further, and the test engineers, they don't know how to test this product at the beginning. They only understand how to test it at the end, when development finish their work, because they have, okay, now I see how it's implemented, and now I believe I know how to test it. So, okay, in this case, this is what happens. Let's say you have the sprint duration 1 week. So your developers are finishing their work on Friday morning, and you're starting your testing at, Friday morning. So you have only 1 day or even less to test that all. And if you won't test it, then the problems come up. Your Scrum Master will ask, why did you don't made it? Why we have to close it? We have a sprint end. We can't postpone those features because the metrics will be broken, etc., etc. So testers usually blamed because of the delayed shipments, delayed release because of that. So how it can be changed? Those risks can be defined based on that criteria and serve as a basis for test cases. So you can create the test cases beforehand, before your testing, before the feature will be completed. So your test cases in this case will be de facto requirements at the end. We're going to talk about this in detail later. So there are lots of different techniques on how to do that. We'll discuss them properly later. So what's about the project risks? There are just 3 types on how these project risks may happen. So the first thing is the organization factors. It's about the skills, personal issues, some wrong expectations. These risks usually should be managed by the project manager. This is the project manager responsibility. What's about the QAs? Sometimes QAs usually helping the project management to deal with some of those risks. Let's take one of these right here: improper attitude toward or expectations of testing. I'm always doing this example. Just imagine. So when developer does something, it can be visible, it can be compiled, and you can really touch it, click some buttons, interact with the interface, and say, okay, well, yeah, cool. I can interact with it. I see what developers are doing for me. So I know I'm spending the money on this, and I can see the result. But hey, what the QAs does, what do they do? I mean, like, okay, I can see the list of defects being reported to the Jira, but is this really everything? Like, okay, I have 10 manual QA engineers, whatever. So I'm spending lots of money on this as a client, but I can see the only outcome is this defects. And even with that defects, I'm releasing the product to the market and still have some defects. So many people do not understand the real benefit of testing. And this risk can be mitigated only with the help of the QA party, with the help of test manager, with the help of leadership, etc. So they could actually establish the visibility to mitigate this particular project risk. So some of project risks can be mitigated with the help of the quality assurance side. Here in the middle, there are technical issues. There are problems in requirements. So the requirements might be, achieved in the written form, in oral form, in any form, in email, in the text message, whatever. So as a result, those requirements might not be the real ones that people are thinking on. So it's the specific on how do people think. For example, if we have some picture in our heads, usually it becomes a problem for us to exactly reproduce that picture on paper. In the good times when I had some offline sessions and trainings, what I was doing is just create an example. I was just searching for some picture with, for example, some animal, just a simple picture in the up on the internet, and I was giving this picture to a person, and this person was trying to explain by requirements on how to draw this picture for another person. So one person was standing and trying to draw by these requirements, but there were always problems with the color, the position, the proportion, etc. So at some point, it's clear for everybody that it's very hard to move the entire picture in your head to the requirements. So this is always the risks. And if we just taking the requirements from a customer and just doing exactly the same way as is being said without thinking, we might come to a trouble, because if we implement those requirements the same way, then technically we did our job, right? But in real, customer won't be satisfied because this product is something different than was in his or her head, right? So this is the problem. How QA can assist on this risk? For example, there might be same risk sessions regarding on how to determine the business value, the business strategy of each feature, what should be the outcome to client, etc. So there are another things QA might help here. And the third piece on this, the supplier issues. It can be a third party that is supplying, let's say, graphic cards to you, and you have to test your application on each new version of a graphic card. So you're expecting to deliver some graphic card, but supplier says, well, I'm sorry, it will be delayed by, like 3 weeks, and it doesn't fit to your release schedule. What are you going to do here? QAs can help there to establish the backup plan on what we're going to do if there will be the delays in shipments. So all in all, project risks might also be addressed with the help of QAs. What about the product risks? Oh, and by the way, you can always use the chat to ask the questions. You can also raise a topic you would like to discuss. I'm pretty open to discuss everything you have at all. We have plenty of time, I guess. So feel free to ask anything. Okay, so what about the product risk? There are 5 different types of a product risks. It can be due to the product with lots of defects. It could be due to a product that may be harmful, that may have the poor characteristics, poor data integrity and quality in general. And of course, the product, they may not perform the required functions or features. So those are types of product risks that might happen. And usually, if we are thinking about the product risks, we are trying to cover each of those types with a certain tests that help us to deal with those risks beforehand. At some point, we're trying to get the list of all the risks in different domains, in different areas, and then to assess them, to provide some characteristics. This is another point of how it's usually done. So when we come up to the strategy risk-based testing, this strategy usually helpful to understand on how those product risks level can be mitigated, on what can happen with our product, what can happen with our release plan, with our schedule, etc. So those risks are usually very helpful to understand what may go not well. At some point, it's very dependent on the type of product you're developing. If you're creating some mobile game, usually it's very hard for you to implement this strategy, because mobile development, especially in gaming, is a very high-paced with the rapid releases, and in this case, you won't even have a time to implement this strategy. There are also some other products that might be safety critical. For example, it may be like I don't know, the insulin pump, right? So just imagine the pump that is created for the diabetics. They are supplying their bodies with the insulin with particular level and some schedule. This device shouldn't fail, shouldn't have a defect, because every defect might lead to the serious injury or even death. So in this case, such devices should be tested at the highest level possible. And even if you put very hard efforts, very large efforts on testing, without risk-based testing, you cannot test properly, because risk-based testing is not only mitigating the risks, it also provides you the information on what should be changed or what might be changed in the product design, in its features, etc. For example, simple case, same insulin pump, it being powered by some power source, some battery, okay? And the good example is, what will happen if this battery goes down? So the wearer of this device will not understand some things happened before it can be too late, because this device won't supply insulin anymore because the power went down. And what are we going to do with this? It's not a defect, right? But this is the problem. So the reaction on this risk may be the design change. For example, another power source, or for example, some kind of capacitor that will still works at some point, or any other changes that may also help to avoid the problem. Because here's the risk, and it gives you the clear view on what can happen, what can go wrong. So if you use this risk-based strategy, it usually helps you to create a proper testing. So the key actions that usually required for that is, at first point, is to allocate the effort based on risk level. So we can measure the risk level of the entire product and think about how, how large will be testing effort. Because if risks are too high, we need to pay more effort in testing. If risks are at the average level or even lower, we can just pay less effort. If we have some risks associated with only some features, but not the entire product, we can focus on testing those features, not the product itself, right? So, okay, the second point is map risk items to requirements. Once we created the risks, we can associate them with the requirements to think about how do we cover each requirement. If we have the acceptance criteria list, we can think on what and how may go wrong. So we can align this risk item to the requirements and then map them with the test cases. So we can usually have the test cases based on the risks. And these test cases usually may not only be possible, but also negative ones. Then we can measure risk levels, what are higher, lower, and prioritize the test cases. Then we come to the testing depth and the level of detail. So usually it's very clear. So the higher risk level, the more detail should be, and the more deep should be testing. More mature test design techniques should be adopted, etc. At the end, we can reflect the product readiness metrics based on the risk levels. We can tell that, okay, before testing, those risks with these levels were here, but now they are here. So we paid this effort, and eventually it led to some levels. So this is only like a high-level description on what happens at the beginning, but let's go deeper. So yeah, sorry, okay. So about the risks attributes, we're going to talk about two of them right now. That's a likelihood and impact. Likelihood, this reflects on what's the probability of arising these risks. It can be measured different ways, by binary, by three levels, by 5 levels. It can be based on the numeric scale, etc. And there is the impact that is telling on how these risks is important. I mean, like how, okay, here's the bug on the slide, right? You probably understand it should be vice versa here. Okay, so the importance of the risk does matter, because some risks may have a high likelihood but a small impact, which means these risks probably will come up, but the impact of it, it's very not important. For example, we are creating the product and we don't have any competitors. We don't expect them right now. So we're creating some niche product. And in this case, we usually, we don't care about the non-functional characteristics, right? Like it's usually happened. If you're creating some niche product, you don't care about everything but features, because this is what brings you money. And at some point, you're thinking about, well, performance defect, it may be slow, but we don't care, because people usually don't have the problems if they don't have the alternatives. This is the way business works, right? You will probably remember the game called Pokemon Go. It's like a first very popular game with augmented reality, right? There was no alternatives, no games like this. It was very buggy, sometimes very slow, crashes often, but nobody cares. People were playing this game days and weeks. So in this case, we don't care about the likelihood of defects. We care about the impact of these defects. But also there are other products that do care about the likelihood and impact. So it's very dependent on your situation, on your case, on your product. So if we can take a look at this map, we can see that the risks might be located in different ways on this map. There are some techniques associated with this case. We'll talk about them later. But in general, it's very important to understand where is your risk and what are you concerned with. So at some point, impact and likelihood can be addressed with the help of different stakeholders. How it can be done. So, for example, there are two ways on how you can measure it on your project, on your product. So about the likelihood, it can be like a numeric form, or it can be based on some levels, like very likely, it's 1, likely 0.9, etc. So there is likelihood and there is impact. Also, the impact usually may determine the way on when it should be fixed. Like if the risk usually 1, so it means it should be dealt with right now. So the same point comes up to the defects. So just imagine if some risk is a defect, how fast, how quick it should be fixed. And then another point, that is the way how to combine those characteristics. If we want to have a possibility to rank those risks, we probably would like to have only one characteristic. So we're doing this way, we just multiplying those. So in this case, you can see that, okay, if I have a likelihood at the upper picture, if we have the likelihood 1 and the impact 0.5, so we can multiply that and have 0.5 in total. So for this risk, with these characteristics, we have the risk level. But imagine you have like 40 risks. So if we can count all non-repeating combinations, there are 6 usually. So in this case, 3 per 3. So 6 combinations. If you have 40 risks, you can divide them by 6, and then you might have like 6 items in each group with the equal risk level. You say, oh, but I want to know, the exact priority. Now I have 6 items with the same risk, and I don't know from what to start. This is the way you can select the 5 item scale, like the below picture. So it can be 1, 0.9, 0.5, 0.25, etc. So 5 levels. And in this case, you have 15 non-repeated combinations. So now, if you have 40 risks, you may have 2 or 3 in each, within each, let's say, level, right? So this is the way how the risk level is being calculated. And sometimes it's very helpful for you to know what's the current priority. And if we're thinking about future, those risk levels are being changed, so your priorities also being changed. The risk that had like 0.89 risk level might be like 0.5 in a week. So the priority is being changed, the risk level changed, so we are focusing on more items now. You may ask, okay, but how do we track the changes of the risk, right? How do we change? How do we understand that the risk is being decreased? This is the very good question. We'll be answering to this question further while discussing the techniques. So why those risks can, where those risks might be helpful. First of all, it can help to understand what test techniques, what test approaches, what test tools to be used. Because if you have the low risks, you may not want to spend much on testing. You may probably focus on some lightweight techniques, lightweight approaches to just cover the product, and that's it. If you think, for example, that let's say the performance might be the biggest risk, so you might be considering the performance testing as a single function, as a separate function, separate test type to be applied. If you're thinking about, well, I have the severe risk that usually tells me that there might be problems with the scalability, so you might think about the scalability testing. It's only very dependent on what do you want to do, what do you want to test. In addition to that, you might be seeing some quality standards like okay, the newest quality family standard is the ISO 17,000, right? So, oh, no, sorry, 25,000, ISO 25,000 family. There are lots of different quality characteristics that a product might have. It's about like, I don't know, 30 or even 40 different characteristics. You know, you cannot test them all. If you might remember the ISO 8126, that was the previous version of this standard. There's been defined only 8 groups, each group with several types more. So you can see 8 groups, like, for example, functional testing, non-functional testing, UI testing, the performance testing, the endurance testing, etc. So different test types. You cannot test everything. So you have to define, what do I need from this? But if we go deeper, there are much more test types that you usually have. Yes, so the compliance to some standards is also a question, because if you're working with some product that should be standard compliant, this is right. You have to conform specific requirements, so you have to test everything. But some test areas might not be required within this standard, but usually good for business, good to deal with the competitors. So this is the way it might work. Okay, so we go to the next point. So how to determine the extent of testing? How many to test? We know that there is, okay, the positive test cases, negative test cases, but we also know about some experience-based test techniques, about some white box testing, etc. So there are a lot of things to do, but what exactly should be done? This is another way where risk can point us. Third thing is prioritize the testing. The way the most critical defects are found at the early phases. Why? Because probably you won't like to change the product much at the very prior to release. For example, you might probably face the same thing in your work life, where you might also like finding some critical defect 5 days before the release, and you're reporting it. Lots of developers are trying to fix it. Lots of changes to be applied to fix this defect, and those changes dramatically increase the risk of a product to fail, because you have only, say, like 2 days to perform a full regression before the release to avoid some regression defects. So this is why we always would like to have the most critical defects at the beginning, and the smallest defects at the end. So we won't change the product dramatically before the release. And those risks usually help us to deal with this. They can do a prioritization for us. And the last point here is to determine on when some other activities might also be employed to reduce the risk. Okay, got a question from Sergey. When the risk is defined in test plan, what's the logic of correct their mapping to test types, levels, features, and other items? Test plans may include the high-level risks that are associated with the business value, but usually if we're talking about the regular sequenced approaches like a waterfall or a V model. So in this case, we always have the full set of requirements and we can define all the risks at the very beginning and put it to the test plan. So we can map them. But in agile world, those list of risks may always be changed because, for example, here's the new feature comes up like yesterday, and the new risks came up. So at this point, we have the new risk set. We have the new list. So we should know to what features, to what test levels or types those risks are applied to change the schedule. So this is why the full set of risks in agile are not put into the test plan, because it's nearly impossible because they're changing pretty often, and there is priorities also changed. So the logic to map it is in the prioritization. So once you know what are the biggest risks are associated, for example, with the integration test level, you're thinking, oh, okay. So for the integration, I should use, for example, like a model-based testing, right? So I can create the model that will be that will correspond to the real product, but I can test it before it will be created to target the proper risks at this point. So mapping usually helps to define the proper test approach with the current risks that we already have. But once the new risks come up, everything's being changed. Everything, like all the tool set may be changed, test levels might be changed. For example, you're testing the firmware, right? You're testing the firmware, and only you don't have any hardware testing for now. The risk is coming up that is particularly related to the hardware. So you might think, you might consider the hardware software test level to adopt it to cover that. So the correct mapping usually helps to understand if the priority is being changed. If yes, then what priorities are changed? Another question, is it okay to define risk level together with teams, or is it good to have just QA's own decision? Thanks, Katerina, for the question. So we'll discuss that in several slides. Usually, the short answer is the risk level are usually defined with the several stakeholders. QAs are not defining those risk levels by only themselves. That's a bad practice. Usually it's being defined together. I'll explain it later in a couple of slides. So all in all, risks might be helpful in many different conditions. So what the value of this? Like saying you would like to use this risk-based testing in your life, in your project. You're coming to management and say, okay, hey, I want to adopt this. And the manager is saying, did you just attend another conference and heard about this and you want to adopt this? And they say, okay, so so what's the business value? Like, why this is better? So there are 3 points. At first point, we can assess what can go wrong. And with proper ranking, proper characteristics, it's easily sellable to the customer, to the client who wants this product, right? So it's very clear what can go wrong, and this may impact the design, it may impact the testing, it may impact everything, even the initial scope. So at some point, those risk assessment can even change the development priorities. For example, everyone may understand that this feature X is very complex and might have lots of risks in it. So they may think, okay, let's implement this feature at the beginning, so we have lots of time to test it properly and to assess the remaining risks. So this may impact even development priorities. Even more, it can exclude some features from the release because the risks might be too high to deal with that. So this is the first point. Second point is to determine what risks are important to deal with. Like, usually if we're adopting this in real life, we are thinking about lots of different risks, but the biggest part of it is usually not important because there are much more important risks. So you can easily prioritize your testing, even if you don't know anything, even if you don't have any proper requirements. At this point, you may be asked, okay, could you please estimate the testing effort for that? You say, hey, I don't have any requirements, but I know only the general picture. Say, okay, I still need an estimate, how you can estimate. So this is all because of those risks. They may help you to estimate properly. Another question, what is your attitude to positive risks? Should QCs also take them into account, access, and build a strategy? What do you mean the positive risks? What are the positive risks? It's like, I can explain a little bit. I can just assume that the positive risks are the risks that provide positive impact instead of negative. So in this case, those risks are not risks at all. Or I'm getting something wrong. Oksana. Yes. Okay, so in this case, it's not called the risks usually. So those so-called the positive risks, they usually deal separately. So yes, QA can do that, but usually officially it's not called as risks because risks usually have the negative impact. This is why it calls risks. If we call the positive risks, better to call it like, I don't know, benefits, like unexpected benefits. Yes, of course, it can be taken into account if you can track it as usual risks. So yes, I think it may be also done, but I would start with the negative risks. Okay. So coming back to the slide, and the third point here is to implement the actions to deal with these risks. This is very dependent on the approach. It may change the entire workflow. So how does it work in real? So like, how does it work in real life? And if I want to adopt those risk-based test strategy, how should I build it? Where to start and what to do? So if you can try to read the books, they will usually say there are 4 activities that are usually very helpful. You can put 1, then 2, then 3, then 4, and now you're good. let's try to play with this as it is a real situation. So there are 4 main activities to deal with risks. First phase is the risk identification. So we should know how to find those defects. There are special techniques that help you to identify those lists. We'll talk about them right now. The second phase is the risk assessment. It's all about to define the risk levels. This is where I will answer the question about who participate in this risk assessment and how to assess those risks. Third phase is the risk mitigation on what actions should I take and what should I do with all these risks I just defined and assessed. And all in all, the fourth phase is usually the cycles activity about the risks, how to put into the cycles, how to deal with risks every time in a circle. How often should I do that? To what extent? What should I use, etc. So there are 4 phrases. We'll be going through each of those. Let's look at the first one. So the risk identification is the process of determining the risks using some techniques. There are 3 techniques pointed here, but there are much more to define those risks. Usually you might think, okay, I can just pick some random and they will be my list. But the good question is, how do I know this is the fullest possible list of risks that might be achieved at this point? This is where those techniques help you. For example, you can see here lots of different techniques: expert interviews, independent assessments, etc. Lots of different techniques that usually might help you to identify. Some of those techniques might be looking too simple, but if you are thinking about some simple techniques as a technique, then you usually come up with, well, hey, yeah, this is like very simple, but this is well structured and this is pretty logical to use it. So sometimes we're missing the good information because it's too simple, right? So we're gonna talk about this. Okay, sorry. Yeah. So let's start from the expert interviews. What does it mean? It means that you have to interview some expert in particular software product or industry or domain. So there should be some person who understands the business domain of this product, who understands the product, who understands the end users. So usually this is like a product owner or product manager or a customer care expert or some of those who are dealing with the business domain, the end users, etc. So all you need to do is to provide the interview, ask questions and receive the answers. So how to define risks? Let's pick some product, for example, let's pick the classic case, the bank applications, right? So the bank applications is something that most of us are using. And sometimes we're thinking, why they are so ugly? Why they are so, so weird? Why are they so strange? So we don't understand lots of it, but usually we're often not satisfied with dealing this bank's application. So, for example, we're assessing the risks of the banking application And usually we know the side of a regular user, but we don't know the other sides of it because we're not backend experts usually, right? So what are we doing? We're calling to a meeting the expert in these applications, some person who designed the requirements for this, who have a large expertise in bank domain, who understands the end users, and ask the questions like, okay, hey, expert, can you answer me what usually the biggest reason of people are like, why people don't want to use it, don't want to use this application? The expert may tell you, okay, this is a security first, complexity second, anything else like I don't know, a fear that your data will be stolen with your phone, etc. So this expert may answer you why this application may be may push back the people from using it. You can also ask, okay, why usually people are calling to customer support and asking some questions? What is the main reason? This expert may answer you, that's, well, the topmost priority, the topmost is the complexity. They don't know what to do, how to do the particular feature they want. Like, first thing. Second thing is they have their application crash, or they cannot log in to it. So once you're asking the questions, you're getting very good responses on what should be tested properly. For example, if you've been told that the people cannot log in, you might also focus some test effort here to think why it can be done. The first point, the people are forgetting their passwords. Okay. Second thing, the people are not updating the application, right? The third point is about that, etc. So you're getting some basis on what to start work with. So you get in the risks and already have some mitigation plans on how to do them. So basically, the source of your risks is the expert who are doing it. So the one technique is being focused completely on some expertise. This can only be not only one expert, but the multiple experts. For example, one product owner, one technical support lead, one marketing person, etc. So there could be multiple experts. It's very important to gather the questions for all of them and ask them and record their answers. This is the very good way to get the highest risks at this point right now, at least some of those. The second technique called the independent assessments. This is usually called when somebody else, not you, some expert who have the experience, have the expertise in defining the risks, coming to you on your side and gathering all these risks for you. You might think, okay, so it looks like an outsource for me. Well, it might be, but here's the point. If you're developing, for example, if you're developing some product that you're not completely good in business domain of it. For example, you're creating some product for gambling. You partially know the theory of games, etc., but you don't know the specifics of this product. You need a consultant, you need somebody who can show you the risks of creating this product and where could be a problem. It may also include some laws, restrictions. It could include some, some other things. But this is another technique to invite a person who is good at this business domain, who already done such projects before. So this person can provide the consulting, can answer you what risks you might be expecting. This may be related to everything. For example, you're creating your own cryptocurrency, right? Of course, you can read the internet about how the Bitcoin works, how the working other currencies. You think, okay, well, it's pretty simple to create that. I can just, I just copy it and give it another name, but you've never developed such product before, and you don't understand what risks might be there. So you'd better invite some person who already done it. And this is called another technique, because you cannot gather the risks from the product you've never done before. And even with that said, it made another point. Let's say you're creating the product for the surgeonist, right? For the surgeon. You're not a surgeon, right? Me too. And how should I know how to build it without the consultant, without somebody who is a surgeon, because he's the end user. I'm not the end user. You're probably too, but there is somebody who is the end user. And this end user may not only give you proper requirements, it may also give you the proper risks that may happen during the usage of this product. So the independent assessment technique is very important in cases you're not familiar with the product or you are not the end user. There's a question, but if I have NDA, can ask some people, or where should I search for this person? The NDA contract, the NDA document usually can be signed with the different people. So this consultant can be gathered on the market. It can be searched by the recruitment as the usual specialist with a certain requirements, and only after the signing of the NDA with this person, anything can be revealed. So you're looking for this person on market, just like for anybody else, just proposing to sign off the NDA with this person, and after that, you're opening your cards, you're asking questions, and continue to work with this. It can be this way or some another way you might consider, but the very important is, if you are not the end user of this application, you might be missing a lot of risks. So this is the technique you should consider. Okay, the technique number 3, called risk templates. What it's all about. Okay, Sergey is also mentioning, for independent assessments, also a few people should be surveyed, doesn't it? Well, if you can afford it, of course, yes. Like, you're right. If you are doing the, let's say, like a device for a surgeon, you might be surveying different kinds of surgeon, like like a tissue surgeon, like a neurosurgeon, etc. Because the different surgeon professions may require different specifics, and even more. Some people, they like one approach, doesn't like another one. Some people vice versa. So yes, it's for the complex projects, it's very required to have the several experts, but even one of those will be a good source for the risks, because we're not talking about the defining the requirements, we're talking about defining the risks. So at least one will be very helpful. If you can afford more, sure, it will probably benefit more. Thank you for the question, Sergey. So Number 3, risk templates. This technique is usually working for the companies, for the projects. They've been used, this risks-based approach often. So they might create the risk templates that are usually applicable for some kind of project. For example, you have your own company. You're creating the solution for the media industry and for the healthcare, right? This is your 2 domains. So you might be thinking on creating the risk template for the healthcare and for the media domain. So the risk template is the classic number of risks that are usually relevant to some business domain. And before the starting of a project, you can consider those risks, pick those that usually actual for your project, and based on those risks, create some more. So it usually saves time if you have this template. Such templates, they do exist in many companies, especially in outsourced companies. They are being created once, being maintained within some departments, and being shared to the different projects to understand what we're doing with. So this technique is usually clear. Create the templates that usually same for some kind of a product, some kind of a domain, and just use it as a basis. Very simple. Number 4, project retrospectives. This is usually the technique that's starting from the retrospective of some project or some even sprints that usually helps to define the risks. For example, just imagine like you're working on a project and there is always the problem that happens over and over. Each release, there's the same problem. Let's say the problem is the filters in your search doesn't work, or they work very weirdly. Like, you're applying the sorting filter and another filter, and sorting filter that just doesn't work. This problem is over and over happening over and over. So you probably can assume that this problem will also come up in the upcoming release, right? So there is the limited list of risks that are usually repeated over and over. So once you create these retrospective, you can detect the risks are usually showing up. Another name of these risk management techniques is the root cause analysis. You probably heard about that, right? Root cause analysis, yeah, I know that in theory it looks good, but in real, we don't do that. Sure. How we can do that? The simple way is just to understand, for example, what is the, what feature is the most buggy, is the most risky, which feature or which component has the largest list of defects every release. Usually, if you can measure this metric, you can be surprised. There is only like 2 or 3 components that are having most of the defects each release. So you can easily just figure out why those components are the most risky. What are the risks inside that? Get it, describe in detail, and start mitigating. So this is another technique that works well in this case. I can also provide an example of using this technique in another field. For example, by just simply putting the different field in your defect report, saying, okay, this defect was found by who, or found by how? Found by manual test case execution, 1, by automation and regression run, 2, by just random clicking 3, by the product owner, 4, etc. So find some different categories and fill every defect with the way it was found. You'll be surprised what is the main approach finding you the most of defects. For example, I was cooperating with one company. They had about like I don't know, 8 or 10,000 of test cases. That's a huge amount, right? Of course, not all the test cases were run do the regression, but let's say it was like 5K test cases were executed each full regression. And when they adopted this approach, they just figured it out that the manual test execution gives only like 15 or 20% of all the defects reported. And only couple percent, 2 or 3% of them having the critical status. Most of the defects were found by so-called bug hunt. They usually being arranged before the release. So the good question is here, why do we even bother of running all those 5K test cases while we can just arrange a couple bug hunts at the different phases of a product development and get the maximum of defects possible at the early stages? So this is like a little bit off topic example, but still it's pretty good. So the another technique here is the risk workshops. What it's all about. It's another simple way to find the risks. Here you can just finding the expert, somebody who is an expert in risk management, who has the expertise here, and just ask them, okay, could you please work with us? Here's our project. Here's our setup. Here's our requirements. Can you please work with me, work with us, teach us how to identify those risks, what are the possible risks here, so we can learn from it and use that knowledge for the next iterations. So it's very simple. If you don't want to deal with all these complex techniques, you can always get the expert in this, who can teach you, who can work with you together on your risks and answer all your questions. So you can use this knowledge later, right? It's also very simple. Next thing here is the brainstorming. This is what I was telling you at the beginning. So anytime a group of people, QAs, developers, etc., can come together, discuss some things, and to come up with, okay, here might be the problem, here might be the risks, here might be the risk, here and here. So this is called a brainstorming session. So you come up all together, thinking on some items, structure it properly, and come up with a solution. You can ask, oh, well, it looks like in theory well, but how is in real? In real, this is it. You can gather the list of requirements, the list of subset criteria, whatever. You can just go through each item in the list and say, okay, let's pick first item. What can go wrong with this? These. Okay, we'll put in the list, go next. What can go wrong with this? Have another list. What can go wrong with the third item, fourth item, fifth item, etc. So all in all, we can define the risk for each element in the list. It may be the requirements, like everything, and come up with a certain list altogether, what is relevant to this piece or to this product. There are also the checklists and calling on past experience. This is which is relevant to the person itself. For example, the major experienced QA engineers who already have the experience with the risk-based testing. They have their own checklists all the time, and they are being using their own checklists for the different products. Like for example, you've been using these like items in the past project. You had those risks. You can collect it, come to a new project, and think about which of those risks are applicable for this project. Classic, simple case. And the calling past experience usually can make you think about the risks you've been facing as the testing expert before. For example, lots of times, the performance of a search may be a problem. It's very often, right? So you've been testing the e-commerce applications for the past 10 years, and you usually know that the search performance is the problem. So when you come into a new project, you can like say from the very beginning, I'm almost completely sure there will be the performance issue with the search, because you have this past experience lots of times, and you can use this data to find certain risks that may be applicable for some product. This is like the list of the risk identification techniques you might use. They are simple, they are very lightweight, but gives you a good vision on what can you adopt. You can adopt not only one, but even 2 or 3, depending on what resources do you have and what time do you have. What about the stakeholders? How do you get those risks? From who? So there are 2 types of stakeholders you can interact with. It's the business stakeholder. It could be customers, users, help desk, technical support, etc. Those stakeholders, they can help to identify the risk from the business perspective. And look at here. Oh, I'm sorry for the background noise. That's very weird. I have I have a very interesting people living around me. I hope it won't last long. It's a risk of noise. Yes. Yes, completely. That's it. Yeah, we know this risk I would not be able to predict, really, because it's like just listen it. Like, you know, it's like 8 p.m. my time, and what is the reason of doing some repairments at this time? But okay, who knows? Sorry for this background noise, but we're all working from home. We're all working from home, so it cannot just be avoided this way. Okay, so that's for the business stakeholders. One of the good things here is the business stakeholders can assess the impact from business perspective, while the likelihood can be assessed more by technical stakeholders, right? So if you're testing the product for a while, you can think about like how often this risk may come up, or what is the probability of having problems with this feature. If you are testing the product enough, you might be thinking that, okay, I know for sure. I probably gonna do something bad to them sooner or later. Okay, sorry again for that. So for the technical stakeholders, usually can help you to assess the likelihood because they know how the system is being implemented and what are the current issues right now. Okay, you're the QA, so we can use to having some bugs and noise, no problem. Okay, do you hear me well when I'm just talking during this noise? Yeah. Okay, cool. So I just won't be interrupted and just will continue talking and just hope the people will go quiet. I'll just message it to some of them. So let's see if that's come up. If they can do it. Okay. So business stakeholders can assess the impact more, and technical stakeholders may assess the likelihood because you usually know what's the code under the hood, and you can understand how good is the code and in what condition it was being written. So, so you may say for sure that, okay, this is code, this code was very good, written by a good, competent developer, so probably it's stable. But this is written by somebody else, so this might not be stable. So technical stakeholders usually can assess the likelihood, business, the impact. So let us smoothly go into the risk assessment phase. Okay, we gather up the list of risks that we have, and now we should understand on how to assess them, how to provide this likelihood and impact thing. How can we do that? So how to categorize the risks? Usually you can see here the regular quality standards, 9126 and 25000 ISO that can be used for the categorization of those risks, depending categorize that by the by some types that can be grouped together and targeted together. As the next step is to define the characteristics. They not be limited to just likelihood and impact, but those are just two simple characteristics that can be started with. The other ones may be related to the risk detectability, to the mitigation cost, etc., but it's not relevant right now. We're just talking about the simple risk management at the beginning, so likelihood and impact. Third thing here is to evaluate other properties of risk. Okay, we gather at the risk levels, we gather at the priorities, but we also need to think how we can address them. So each risk usually should have the risk owner, because otherwise, if we don't have it, this risk might be forgotten or might be just remain untouched for some time. So having proper risk owner, having some mitigation plan, it's very important to have such properties on it. Let's have a look closely. So risk level can be assessed quantitatively by numbers or just qualitatively, like from high to low, mid, average, etc. So we can pick other ways we like, but the problem is here that we usually always should come up to the risk level. So even if we don't have it, we can use some standardization to have the classification. For example, if you're creating the software for the planes in the avionic domain, you usually should follow some policies, standards. There is a standard for the US Aviation Administration called ED12B for the Europe and DO 178B for the states that have their own classification of the risks. They have even the associated test coverage to it. So if you're having the risk with level A, catastrophic, that you have to achieve the required coverage. I mean the component testing coverage, by the decision statement coverage, and modified condition decision coverage. So for the hazardous, it can be different coverage, etc. So it's not only classifies the risk, but also providing the needed coverage or the needed test types, test efforts associated with the current risk. So you can even use this categorization scheme instead of creating your own, like we were just seeing with the numerics, or some levels, right? So this is another way, but for the most of products, there are no different, no specific classification to do that. So this is how it is. So what factors do influence likelihood? What we should consider? These factors should be considered before the risk assessment at all, to understand what to multiply. Because, for example, the overall risk may be different from a product to product. Because, for example, if you have the complex technology or a complex team set, that you have a total higher risk than from another step. So the more factors you have from this list, the more total risk you have. So the biggest, so the bigger test effort should be adopted, should be used. So these factors are for you, that will help you to establish the general risk level, to understand what will be the test strategy for the entire product at the beginning. So this is the complex technology. It can be a new technology, right, which were not tested properly even. It can be like a new version of an Angular framework, right? So there are the risk that the developer are not learned enough the new version of a framework, so they don't know quite how to effectively use it right now. So this can increase the risk. Second thing is about the personnel and the training issues. It's all about the, for example, time pressure. Time pressure greatly increase the likelihood of a risk, right? So every good manager knows that the more you push on people, the higher the risk is. So every good manager should always thinking about the trade-off between pushing people and between the general risk level. Sometimes if you're pushing too high, you may get things much worse than it could be without the pushing people, right? So this is another factor. Third thing here is a conflict within the team. So in some cases, when your team doesn't work together properly, they may increase the risk, because if somebody says, okay, I don't like you, I won't work with you, and I will see you're failing, you're doing something wrong there, but I will keep quiet just to set you up, right? So this increases the risk level too. The problem with the suppliers, the risk associated with the delays. The suppliers, you may be having a new supplier for the equipment, and there is another risk because the new supplier might not be reliable. Your team might be distributed at the way, like part of team are sitting in California, part of the team are sitting in London, and part of the team are sitting in Japan. So you know, like completely different time zones, completely different interaction between them, and it's very hard to negotiate at some points. People are starting to make the assumptions. They can't verify it because it takes too long to do those emails. So it also increased the risk level. If you're dealing with a legacy, if you're applying some new approaches on it, it also increased the likelihood. The same as the new tools, new technology, it all influence the likelihood. It always increases the likelihood. Or instead, you can use, for example, the old tools, well known, and people are used to use it. So these can also decrease the likelihood. Also, weak technical leadership and weak leadership at all, it also increases the risk. If there is no leadership on a project, it could come up at some point with a group of people that are doing something without any strict focus, and they all can just wasting their time on something. So without good leadership, the risk likelihood is being increased. The time, resource, budget, management pressure, this is what I was talking about. This is also increases the likelihood. If you don't have the early testing, if you don't have the quality assurance at the beginning, if you're dealing with quality assurance only in the end of a development cycle, it also increases the overall risk because you don't having any feedback from the product while working with it. High change rates, high defect rates at the early phases are usually also increasing the likelihood because the often you change, the higher the risk. If you're seeing the metrics and see that, oh wow, I have like many defects at the very first day of testing, it means that product is not stable. It also increases the risk. And of course, the interfacing and integration issues. If we're feeling that to integrate with our product takes a severe effort, that might be not only the problem with the tool we integrate with, it might be also the problem with our product, right? So regarding the impact, there are also a list of factors that do impact the impact, like they influence the impact. So first of all, it's frequency of use of the effective feature. I mean, like if there is the feature that is being used very rare, in rare cases by rare customers, the impact won't be so big as if this feature will be very popular, right? So the role this feature plays in achieving the business goal, it also the factor that influences the impact. How critical is the feature to accomplish the business goals? This is the question we should ask to define the risk impact. The damage to reputation, in case this risk come up to life, is also should be considered to determine the impact, because some risks may not look scary to us until we think about the reputation. For example, we might have lots of competitors, but like, okay, for example, our strong side across all these competitors was the good performance. Always was it good. And people were always buying our product because they know that, okay, here it always good performance. Perfect, I want this. But what if we'll have the performance issues in this release? Our reputation will be damaged in a very bad way because people think, okay, what should I pay for that if the performance was the really good before, but now it's poor. So why should I bother with this? I would just go and buy from a competitor. They have much better interface, right? So some risk may come up with a very high damage to reputation. It also can come to a loss of business. For example, some risks, if they come to life, you might be sued, you might be come to some penalty, you know, some, you can have some social losses, or you can create some financial losses to the country economic or something. So eventually you can lose your business and even may go to jail. So this is also can be considered. There can be some legal sanctions for you if some risk will come up. For example, if you create the software for the planes and you were not testing it properly, you may be having sanctions against you with the loss of license, with a high reputation impact because of that. If you don't have reasonable workarounds to deal with some risks and problems in this particular area, your impact also grows, because if you don't have a workarounds, this problem might be the big problem for you. Okay. The visibility of the risk to the public. For example, if you're having your own social network, right? Saying like a Facebook, just imagine if at some point all your private pictures, videos, what you have can be opened, can be seen by public. You will be very, very frustrated. So this will also damage everything. So such risks may also have a high impact. And of course, the last point here is safety. Of course, if this risk is connected with safety, with any kind of safety, it's always usually have the highest impact possible. So it also should be considered. So while considering all those factors impacting likelihood and impact, you can think eventually on the total risk for the product, for the project, for the feature, and even for each risk in your list item. So all stakeholders who are working together on the risk, they can think on each of those factors to evaluate if they are fitting to this particular case or not, and to evaluate the risk based on all these factors, knowing them. So with all the stakeholders, we should be aligned at the same point. So after reading all these factors, we all know what we're thinking about the risks and the factors that are being influencing the characteristics. And the risk mitigation phase. The last one is here. So risk mitigation is the process of managing with the risk. Here's the question: how objective can be assessment of the external factors? Usually, if one person is being assessing some risk, then it's more subjective. But if several stakeholders getting agreed on some particular risks or characteristics, it gets more and more objective. So basically, if you gather QAs, developers, business representatives all together and estimate all together, you have the maximum objectivity possible. So if you're assessing by your own, it can be very subjective. But if there are lots of stakeholders, the representatives from the different functions all together, it can be very objective. So yes, to establish some objectivity, you need the different representatives, the different stakeholders participating in this. So risk mitigation. Basically, you need to know how to deal with those risks. There are 3 regular ways to do that. The first thing is testing, static and dynamic testing. Static, I mean the reviews, the static analysis, and the dynamic with the test cases and execution. This is one of the most popular ways to deal with the risks. Second point is risk contingency. The plans that we are creating in case we have this risk. So we're basically thinking on what are we going to do if this risk will come up. So we can just create some plans and implement them, use them in case this risk arrives. Having such plans, it's very good in case you cannot remove the risk with the tests properly. So you can only think your strategy on what will you do, because if you don't do that and risk will come up, you will be rushing all around and thinking, what am I going to do, etc. So better to have such risk contingencies. And one of the good points is that accepting the risk is also a way to mitigate it. Really, some risks might have very costly mitigation ways, and it's cheaper to just accept it and forget about this than deal with it. So it's also should be considered. I'll discuss, I'll explain on this later when we will be talking about the techniques. So basically, we can align with the low and high risks different approaches. Like we can select the test techniques based on risks. High risk, more meticulous test techniques, pairwise, white box testing, etc. Safety-related standards. Low risk, more like exploratory testing, experience-based testing, cross-partition, etc. If we're thinking about the level of detail of the work products, if low risk, it can be less often, less documented. If some features are not risky at all, we can just create the checklists instead of test cases. If the feature have a high risk, then we should have the detailed test cases in it, right? So this is the answer on how should we pick the level of detail of a test documentation. Sorry. Level of independent testing. So if we considering the independent testing to be adopted, for example, like outsourcing some testing or some expert-based testing, we can think about risk levels. So if it's low risk, depending on the software development lifecycle, we can just or accept it or just do not adopt it. If it's high risk, we can create additional test levels with a certain level of independency. For example, we can create the acceptance testing level being performed by the independent team within our organization or externally, even that. We can also think about who will be testing what. So features with a low risk, it can be covered with a less qualified testers. While high risky features can be tested with more qualified testing. Also, we can think about the degree of the confirmation testing, regression, etc. So if it's low risk, they can be only high-level regression testing, only like a check boxes, running several tests, and that's it. If it's the high risk, then it should be well-defined, partially regression testing to be performed here. So this is how it goes. And When we come to the discipline called risk management, we usually adopt all these 3 phases in the cycle to understand how can we deal with all of this. So this is the way usually it works. So once we adopt the risk management in the life cycle, we usually put all these details to some test policy or some test strategy document that already explains on how do we adopt it, what risk characteristics do we use, what phases, which approaches do we adopt for the risk identification, for the risk assessment, and for the risk mitigation, etc. So we usually can document that to follow this procedure each cycle, right? So we have a full cycle dedicated to, let's say, like for the release, we can map one risk cycle to the release or one risk cycle to the sprint, even that. So all in all, we can define the risk-based strategy in detail to prioritize and sequence the tests. So there are 2 ways, actually. The depth first, it's saying, okay, so if we have tests for the lots of features, we can just take the tests from the all the features and run all highest risk tests before any other lower risk. So for example, if there is the feature A and feature B, feature A have the highest risky tests, there are 20 tests for it, and feature B have like 3 tests that are low risky. So we'll be covering fully feature A, and only then we come into feature B. So in this case, we won't have the response of a quality, we won't have a feedback on the quality of feature B before we test, we execute all those tests in feature A. But if we use the breadth first, so we have to select the highest, the test with higher risk for each feature and run them first. So 3 tests from this feature, 2 tests from this feature, 5 tests from this, 3 from this, 5 from this, etc. So we're doing the breadth first approach. To have the quick feedback from every feature to understand if we were good with the prioritization or not. So this is also the way how to adopt the risk management strategy. Okay, so what I'm thinking right now is to have a break, like for 5-7 minutes, so we can just take a coffee, tea, just water, and we can continue on the next topic. So the next topic will be the techniques that are used for the risk management. So how do you think? Will be good? So what would I assume? Okay, we have like 49 minutes right now. So I'll map it right here and we can go back in 5 minutes. Okay, so it could be like 54 minutes will be start. Okay, so we have the 5 minutes break, and then we'll continue with the risk management techniques in detail. Okay, so let's have a break. Okay, hope we're all back after a short break. So just gonna share my screen. Okay, so now we'll be talking about the techniques itself. So once you understand all these basics, you need to know how to apply all this knowledge in a real project, how to deal with this in real life. So we can actually think about on what are the most common strategies to use on your particular project, on what's the most optimized, which is least optimized, which helps more, which helps less in what situation. Sometimes it's very hard to understand if this might fit in your case because you've never used it before, and you have the good question on, well, will it work or not? So we'll be talking on this right now. So there are a list of the lightweight approaches and the heavyweight approaches that you might use. The lightweight approaches, that are those who usually help you to understand which of those are good or not. So this is the systematic software testing approach being defined by Craig. There is the PRAM, pragmatic risk analysis and management, being defined by Rex Black, and Prisma, product risk management, created by Eric van Weendale. So those all approaches are usually comparably easy, but they are not that easy as we're thinking about the techniques to identify a risk, etc. So each of these techniques has own book written just on the process, on the live dealing with this, and it may take an hours to cover even one of those. So I'll just will briefly describe the benefits of each of those, and we can together take a look on the high level of which of those will be relevant to you and which of those you would like to use, or even how you can combine them. So, for example, we can start with the SST. So SST, systematic software testing, require specifications as an input, and it cannot be used without those specifications. While Prisma and PRAM can basically work with any kinds of input without specification. It can be based on any stakeholder input in any form. So this is how it separates. So if you have the proper requirements, SST might work for you. If not, only Prisma and PRAM can be used in your case. So what's inside? Okay, I probably have a duplication of the slide before. Sorry for that. Just keep it. So for the documenting the quality risks, we have to think about the template. So template is something that may serve as the baseline for all your risks. So you have to think about different fields that are in this template. So for example, it can be the risk category based on your categorization scheme. It can be likelihood, impact. It can be the risk priority number. It can be the extent of testing being applied to a particular risk. It can be risk owner. It can be tracing to some requirements, some risk basis, etc. So this template usually serves as the way of tracking. This template is usually being used in PRAM, Prisma, and SST. All of these lightweight techniques have a little bit different template, but it still does work properly. Different, but aligned with the general approach. What I'm talking here, the SST looks this way. So SST, systematic software testing, has like 10 phases that you can basically use to go through all of these 4 phases of, the risk definition, risk assessment, risk mitigation. So totally, there are 10 phases in the SST approach that goes this way. First thing, you are creating the brainstorming team, which means you have to define who will be the good stakeholder to define the risks. Usually, it may include the testers, developers, some business representatives, marketing specialists, even end users. Once you have this brainstorm team, you have to consider specific rules for your project. Prepare to the number 2 to create a list of features by this brainstorming team. So here, what it may look like. You have to complete a list of features, to compile a list of features that can serve as a basis for your risks. So you can start working from the requirements in case of systematic software testing, but also you can start from features while working in different environments when you don't have the particular requirements. So each feature mentioned here will be a basis for creating the risks on the top of it. Let's imagine that we are doing some testing of the ATM software, right? So ATM software, it may be like have different feature: withdraw cash, deposit cash, check account balance, transfer funds, etc. So there are different features on it and couple attributes that works properly. So maybe usability, performance, security. All right. We can assign the likelihood to each of these, the likelihood of failure of particular feature, maybe high, medium, low. So we remember who is the best stakeholder in defining the likelihood. That's the technical stakeholders. That's the developers and testers, because they know how this product works, what is the code is under the hood, and what is their previous experience with development or with developing and testing it. So there are like different voting concepts. I won't use it here. I won't describe it here, but usually it's simple. So everybody is voting for particular level, and then we're all together deciding who has the closest opinion and trying to agree on this value. Works like the same way as is done, for example, in playing poker, right? In Scrum. So same way. We achieved then the likelihood of a problem with feature withdraw cash is high, but one of the the reasons of the ATM being created is the possibility to withdraw cash, to get a cash from it. So this will be the first priority for testing overall. Then there is the feature deposit cash. It may have medium likelihood, but we may think about impact later. We estimated that it's a medium likelihood. Check account balance is low likelihood. There are no large risk in it, etc. So we put the likelihood in each of it. Then we think about the impact. We think that, okay, withdraw cache and deposit cache have both high impact, because for us is very important to ATM have properly working both of these features. Because, for example, our competitors, they do not have the deposit cache feature, but our ATM have it. So we should put the high impact here. We're also estimating the other features and the attributes at some point. We estimate the usability and security as high, because if there is the problem with the usability or security, people won't go with our ATM or with our bank at all. So they will change to competitor. So this is important for us. We put the impact properly. On the stage number 5, we will need to calculate the risk priority and assign numbers. You remember, right? So if we're estimating the likelihood in impact, not in numeric form, we'll need to come up with some risk level. We need to multiply them, right? But how can we multiply high on medium? There is the approach that can show you how to do it. That's right here. So you can basically say that, okay, I can assign a number to each of those and can just do multiplication by the according number. So I can do it this way: high multiple by high. Here 3 by 3 comes up to 6. So I can have the priority 6. This will be 5, this will be 3, this will be 4, etc. So we have the priority to work with. We have the priority for the testing, and we also have the metric to track on which approaches, which strategies to use. Next, phase number 7, we have to review and modify the values. Why this is important? Because once we define all these numbers, for example, let's say we have 10 features. With each new feature, we understand the assessment approach more and more. And at some point, you may think like, well, I might think more about the 0.2 or 0.3 because I have some new information here. I would like to review and modify it. So it's very important after the initial assessment to come back and review each of those again, to think about the team history. So what was before? So can we change something according to the history we know with this? So the experience of developers or the experience of some stakeholders can affect the priorities and say, okay, even if this risk here is too low, we still want to have a decent priority because we have the marketing strategy that states this feature is one of the killer feature of this new release. So we better test it too as a first priority. Okay, no problem. Same thing with the complexity, with the usability that may increase the, while we want to get the people using our application, we create the large of design features, usability thing. We can increase the complexity of the software by doing it. So we might also consider this, how to manage with it, how to manage with this, because in case we don't have enough testing resources to cover that, maybe we should postpone it. Same thing we can do, we can consider if this feature is new or it's a modified feature, because it's also can influence the the characteristics of the risk. So basically, it's very important for us to think about how these numbers might change in future and come up to the certain list what we have here. Because on phase number 8, we should have the prioritized list of features based on a priority. So we can completely see that, okay, we have to test these 2 features and these 2 attributes at first, and only after that come into other feature and attributes. The interesting point here is that you probably remember that maybe you're reading some test plans, some standards related to test plans. They were mentioning the 2 topics: features to be tested and features not to be tested, right? So you're thinking how it can be, how we cannot test in some features. Here's the point. So once we have all these in priorities, we can think on where is the cut line. So what we should test and what we shouldn't test or test less at very little point. So we can actually establish this cut line saying, okay, this will be tested very good. This will be tested somehow, and this won't be tested at all. And to understand this cut line, it's very needed to think on what this cut line means. Usually it says like, okay, what is in green, what is to be tested means that we'll have a test cases, we'll have a test design it, execution, put it to regression, etc. But what means red here? It means that this feature will be manually experience-based tested, and that's it. No checklist, no test cases, just being going through, and that's it. So this is very important because we cannot test everything. We know it. And we also know our schedule and resources. So we know where is this cut line. And once we have this, we have also developed the mitigation way on how do we deal with all these risks. For example, for the withdraw cache, after the meeting, we decided to provide the code inspection. Code inspection will help to remove the underlying defects that might be in the code right now. For the deposit cache, we would like to do the early prototyping to remove the associated risk with it. And for the usability, we would like to have the early user feedback that will help us to know if the usability is good and on which level. Let's say on a 10-point scale, like it's 5 or 7 or even 9. So in general, this SST approach usually helps you to understand how it's being managed together, saying like anybody who even doesn't have an experience with risk management can take this, implement it, and get some decent result. So, you know, there are some different ways that helps you to understand that, okay, well, this is pretty cool. I know it. Then like, okay, I should do this, then this, then this. So I can even plan it properly. I can even present it to the management and get an agreement on something. I can estimate what effort it will take and so on. So this SST approach is very useful if you want to go in this way. For the Prisma key feature, they have different, similar process with all this, but the key feature of Prisma is presenting risk assessment results in these risk metrics, in this kind of a diagram, which is usually important to see what risks do we have usually? So likelihood here, impact here. Okay, we can see it, but the best thing is here is that you can see the blue circle at the center of it. What does that mean? It means that if a risk is inside this circle, let's just draw them by here. Okay, for example, if there is a risk right here, right, X, it might go very fast right here, or here, or here, or even here. So if the risks are within this circle, it means those risks are the most unpredictable. They can go either way. And so this risk inside this circle should be carefully estimated and tracked regularly. So the risk outside of this circle can be tracked and re-evaluated, let's say once per month. But risks inside this circle should be evaluated every week, for example, right? So taking into account the policies, we should understand the movement and the dynamic of movement of those risks. For example, we can talk about the dynamics. So Prisma says that the dynamics is very important. For example, this picture we have right now. Let's say after the testing, we have this picture. These risks, the risk went here, impact was decreased, this risk went here, this risk went here, this risk went here, this risk went here. So we see the old dynamic, the risks are decreasing at some point. Some of them are increasing, but we understand the dynamic right now in a month, in 2 months, in 3 months, etc. So we can measure that. We can see the dynamic on how do we going well or not, because there might be another picture, like saying that previous release there was this risks, but this release risks are going here. This risk is going here. So at some point we can see that risks are changing in the better way or the worse way. So we can measure how do we deal with them effectively or not, because with time those risks should decrease. If they remain or if they are growing, it means that we're doing something wrong. So Prisma is all about the dynamics, the presentation of these metrics in a proper way to understand where are they going, and also to predict the picture. So there are also some techniques within Prisma that allows us to predict where will be risk level in 1 month, or 2 months, right? So I won't go into details here, but still, if we know that the likelihood will decrease from 19 to 13 here, from let's say 20 to 9, etc. So we can do the prediction based on like, okay, this month we would like to run, let's say like 300 of test cases associated with those features. So this risk will be decreased by half because half of tests will be running right here, right? Or decreased by half because there is another test type that will cover the another half. So in this way we can predict it, and then we can predict it and then re-evaluate at the end of the month to see if our prediction were taken were realistic or not. So this is what I mean. So for the PRAM. PRAM is more focused on the testing depth. So while Prisma is saying about the dynamics, about the prediction of risks, PRAM says more about the testing depth. So what it does, usually it creates the certain association between the testing depth and the extent of testing. So you probably remember I was saying I was showing this template from the standard in saying, okay, we need the, okay, I just go back here. Okay, too bad I didn't put it here, but sorry, I have to go back here. Okay, here. You can see the slide, right? So we can have a risk, and here we can put the extent of testing, which can mean extensive, broad, cursory, opportunity, whatever, here. And the reason of PRAM is mapping certain testing depth to certain risk levels and certain extent of testing to the testing depth. So basically, when you see the risk level, the number, you can just literally go to the extent of testing and just do it as it is mentioned there. So this table, they have their own template on this, but you can create it by yourself. So I did it here for you. Well, in case of there is testing depth extensive, I can have here certain combinations here. For broad, I have different recommendation. For cursory, I have different here. For example, some kind of features, right? You remember, it was said not being tested. What does it mean? It means that the testing depth could be report bugs only, which means it's not covered by formal tests, but still it requires the general walkthrough through the main combinations. If we find bugs, we report bugs. And even it have non-testing depth, which means that neither test for these risks nor report related defects. So we don't even report such defects if we find them. So this is PRAM is more about testing depths, more about the templates associated with the general workflow, how they do it. So basically, you can combine different ideas and use it if you want to have the lightweight testing to be adopted. So why do I put exactly those features here in this document? Because usually it's a very good combination to use it in real. So you use SST, you use this risk matrix, and you use these templates for the testing depth. So altogether, you may have a really solid risk-based testing implementation. Also, it's here the practical exercise for SST. So you can do it by yourself. I know there are lots of people here, there are 40, and if we start to work on this like in detail, we can go deep here like for hours. But generally, if you would like to play with it, I have here the movie subscription system for you with a list of features and attributes. Try to think more on how would you estimate the likelihood and impact of this feature of this particular product, and what will be the testing depth requiring for each of those according, for example, to this template. Just think on how it will be good for you. So you would ask yourself lots of questions during the determination of likelihood and impact. If you exactly remember those factors, sorry, those factors that are influencing likelihood and impact, right? So you can do a little homework here. Just go there, remember all these tricks, what I was explaining here, and put likelihood and impacts here accordingly, thinking about those factors, calculate risk levels, do the prioritization, and set testing depth required for each feature, and create a cut line. So you can go through all this way only by yourself, which also will give you much more, much more information regarding this topic in real. So you can actually implement it in future much better because you already did that, something like that. So this is for you. And also the last topic we have for today is the heavyweight approaches. There are 5 approaches that usually called heavyweight because they take lots of effort, and usually they have been used in some safety critical systems, in some prototyping, in even designing the solutions. So this is hazard analysis, cost of exposure, so-called Fmea, Fmea, failure mode effect analysis, quality function deployment with this house of quality, and of course, the fault tree analysis. So those 5 approaches usually very helpful if you need very detailed and clear risk analysis. Those are rare cases, but I'll provide the examples with each of those, so you would understand the very beneficial factors for you. So let's have a look closely. For the hazard analysis, what is this all about? Hazards, this is something that follows the risks, right? So basically it's something that underlies the risk. So risk brought some hazards in future. So to define the hazard, we need to define the risk first. So what we're doing in hazard analysis, we're not only defining the risks, we're defining the hazards that underlie each risk. What it means. For example, we can also classify those hazards. Like, what hazards could be? For example, let's just imagine something. Okay, so here's the reason. I have a power bank. Okay, I have a power bank, and I have a risk that this power bank may go on fire, right? You all remember things when certain flight companies does not allow you to bring the power bank on the board, right? In your hand luggage, just because of those accidents. So, okay, you have a risk that your power bank will go on fire, but what hazards might underlie in it? A good question. First hazard might be, it may lead to explode, right? Because you may use some different kind of batteries inside. It may go, it may cause some injuries to the person who holds it. Third, it may go to some intoxication by people who are breathing the air of all of this, right? So et cetera, et cetera. So you can find lots of hazards underlying each risk. And then you would need to classify those hazards. So just imagine it. You can classify the risks with likelihood, impact, etc. And then each risk goes to lots of hazards that also should be classified by some assessment metrics. Like in this case. So the hazards should be classified by the frequency of occurrence, because if your power bank will go on fire, there is not 100% probability that it will blow up, right? But there is certain frequency of occurrence that might happen, and we need to estimate all of that. So there could be several hazard categories: catastrophic, critical, serious, minor, and the frequency of occurrence. So you can see the same approach, right? Same likelihood and impact, but with a different point of view. So once you go in this, you understand every risk very, very deeply. And it takes a lot of time to classify all these risks and all the hazards that underlie with it. So the good question, why do we need hazards? Why do we all need it? The answer is sometimes when we can't mitigate the risk itself, we can mitigate the hazards that underlies on it. And while we're mitigating the hazards, we're mitigating the risk, right? So if we can remove some hazards from this risk, the general risk impact might go lower, right? So this is why we need those hazards. In a complex solutions, in cases where we have lots of features to cover, and especially if we're doing the safety critical software, we need to pay specific attention at the hazards underneath. So what's about the cost of exposure? I was talking recently regarding the price of dealing with some risks, right? So there is the mitigation cost and there is the risk cost, and we need to figure out somehow what costs more, the mitigation of risk or the risk itself. So it also responds to a question: should we accept this risk or better mitigate it? So this is where cost of exposure comes to play. This technique is not specific to the testing, not specific to software development at all. So this example I can provide with a little bit different topic from marketing. Let's have a look closely. So we have here several tables and formulas. After 2.5 hours of training, we're just like, what? Okay, what formulas? What? I need to think. Okay, here's the interesting thing. So just follow. It's a heavy slide, you know, but just follow my story. So here on the top of it, we have 3 risks that might happening with our project. First risk is the product recall situation. So there might be a case when our product can be recalled from market. For example, you may heard about the Tesla recall from market due to some sensor bug, right? So it's about like tens of hundreds, tens of thousands cars were removed from market, and it also have some risk in it. So, okay, there are 3 fields we would like to fill here. Is the probability of occurring? Marketing does that usually. Let's say it's 2% that it will lead to the product recall situation. There is the total loss might happen if this occurs. Let's say if it's 80K. And there is the risk exposure is being counted as 2% multiplied by 80K. So risk exposure is 1,000, is like 1,600s, right? Okay. So this is risk exposure, which show us what is the most, profitable risk here. There is another risk is called the significant product rejection. Then means that people won't just buy our product for variety of reasons. So there is a probability of occurring only 0.1%, and total loss is 100K. So risk exposure will be 1,000 here. And there will be the competitive strike, when our competitors will also release something that might impact our release. So the probability is 10%. And total loss, if occurs, to 25K. So like a 25K we might lose if our competitors will come to strike. So the risk exposure will be 2,500 here. Okay, so what are we gonna do with all of this? We see, okay, we see 2,500 is the largest risk exposure level here. So, but we think, okay, well, it's still high probability, but total loss is pretty low. So we better estimate each of those. So what are we doing then? We're taking, for example, this competitive strike and thinking how we can change it, how we can mitigate it. What can we do with this risk? And we do the same for each of those risks. Here below the table, what is done here? So we are trying to calculate the risk reduction leverage. This parameter tells us what is the most effective countermeasure. Okay, so we do it here. We think, okay, there are 3 countermeasures that can be applied to the competitive strike. First is the advertising campaign. So we can do more advertising and save some probability here. So we can spend 40K on advertising campaign, and new risk probability will be 3% from 10, so decreased by 3 times. And new total loss will be only 5K. So we can calculate new risk exposure will be just 3% multiplied by 5K, and we have 1,500. So risk reduction leverage will be this number. But here's the point. Why should we spend 40K on campaign to save 20K, right? 25 minus 5. So why should we do that? So this is not effective, so we can exclude it. Then we can do the price promotions. We can offer some discounts. This discount will cost us 30K. So, and the new risk probability after this discount, we know the prices of our competitors, etc. So now it will be 5%. So dropped by twice, and new total loss will be 10K. So we see here that we'll pay 20K for saving 15, right? Because 25 minus 10 will be 15. So also from formulas, it's most cost effective countermeasure, but it won't work because we spend more than receive. And of course, there is the simultaneous launch. We can launch the same day with a competitor, and it will save us, let's say, 25 minus 15, 10K. New risk probability will decrease only by 2%, and it will cost us exactly the same money that we're going to spend. But in this case, risk will be reduced by 2%. So this will be most effective countermeasure. Those will be the most effective countermeasure, even if the risk reduction leverage is very small in this case. So, you know, it's like a complex thing, but if you can try to map this technique on the product risk, you would still can estimate the new probability of risk. You can estimate the new possible loss that could cause this risk. And you can think about, should we even deal with this or not? Because test efforts, for example, right? For example, we have the risk in performance. We should calculate, we should talk to the product owners, to the marketing, and figure out that, let's say, how much that will cost to us if end users will find the performance issues. Marketing can do this, can do some surveys, some research, whatever, and can tell you that, okay, so roughly 5% of all users will stop using this software because of performance issue, and will go away. 5 users. For example, the expected revenue will be the $1 billion. Okay, so if 5% of this revenue will be lost, this is 50K, and we're thinking, okay, should we do the performance testing? Should we do the good performance testing here? What is good performance testing? Let's say we have to buy some performance testing tool. For example, like a decent performance testing tool will cost you $15,000 per year, and including the resources, planning, etc., it may be cost you like $80,000. So why should you even bother with doing the performance testing if you will lose only 50K? So this can be applied to everything. And to calculate these countermeasure, and even to calculate if it's possible, you have these formulas, you have this approach, you know how to deal with this right now. How to calculate probability of occurring. Okay, so here's the thing. In marketing, it's usually pretty clear because they have the surveys, they have the dynamics, the coefficients, etc. What we can do with a product, what we can do with the product risk estimation, we can basically track how often the related defects are happening. For example, if we're talking about the performance testing, and for example, we have like only 1 or 2 defects found within release related to performance testing, then we can say, okay, the probability of occurring is low. I would say, 5–10%. So the accuracy, let's say, it will be 10%. So like we can say 10%, 20%, 30%, 40%, 50%, etc., but not like 15% or 23%, right? So we can say, well, we have so low defects related to this, and in previous we didn't have any defects related to this, no customer defects to this. So I would say like the probability is like below 10%. Okay, map it here. But what if some feature have the probability, had the defects during testing, had the defects from customers, from end users through technical support, and we see the high risk levels. So we can say, okay, the probability of these defects, I would say like more than 50%. I would say like 60%. Somebody say, oh no, maybe still 50%, but still you see like the difference is like within 10%, 50%, 60%, it doesn't matter much. But if we can do the performance testing, we can clearly cover this probability will go down, let's say, to 10 or 20%. We just need to figure out if this drop by 30 or 40% worth the cost spent on it. So this is what we're talking about here. Okay. Okay, so let's talk about one of the biggest and most complex technique being used in risk assessment management. It's called failure mode effect analysis, FMEA. So this is all about gathering as much information for risk as possible. So the reason is here is to describe the risk to the lowest details possible. There are many templates related to this technique. You can just type in Google FMEA template, and you will find at least a dozen of it. So it's not a problem. There are actually some standards that have their own some templates. One of them I will show you right now is the part of a template for the testing avionics software, or actually the avionics itself. It's from that standard DO 178D from the US Federal Aviation. So you can see here there's lots of columns, right? You can see here that the item right here and the many characteristics associated with this, right? But this is not all. In really, it's twice longer. I've seen such templates with 35 columns in it. So it's a lot of data for each risk. So what is here? We can see here that item is, for example, the brake, one of the brakes that the plane has, right? Brake, which is the potential failure mode. It's some kind of leakage from one channel to B. There is potential causes, mechanisms, when it happens, what phase, what are the local effects, what are the higher level effects, system level effects, probability, severity, detectability, etc. So lots of components, lots of characteristics related to each risk. So once we're having some kind of risk related to something, we're gathering as much data about it as we can and put it to these templates. And based on this template, we create the tests. So basically, you can see this one item. I would assure you that only this one item can be covered by 100 of the test cases, or well, at least by tens of the test cases, to verify all of these local high-level effects, system-level effects, some detectability, etc., some failure modes. So in result, this item can result to tens of test cases. So once you have this template fulfilled with saying like 50 risks, that can result in the thousands of test cases, even like tens of thousands of test cases, only based on risks. And this is why it calls one of the well, I would say maybe the toughest, the most heavy technique for risk management, because it takes a huge amount of time to implement. For one project, I saw like about like 10 months are spent only on this template. So 10 months of working of a team of QAs. I don't remember how many people were there, but still, it's all because it was required by standard. It should be standard compliant. So this is why this template should be fulfilled to get a license for the product release to market. So this should be done, but it took like 10 months of a team. I don't know, maybe like 8-10 of people. So that's a very, very large effort, and also should be considered. About the quality function deployment, what is it? Usually, it's very rare thing because like nobody usually talks about it because it's mostly used under the design phase. What do you mean under design phase? It's like when you're designing some feature or the entire product, you're going through different trade-offs between, let's say, you have a smartphone, right? Your smartphone may have maybe small with a small battery, but the uptime will be less. Or the uptime can be bigger, but you need a bigger battery. So the bigger smartphone will be and heavier it will be, right? So you need to find the trade-off between the weight and size and the uptime. So you usually don't know how to deal with such risks. What users would like more? The heavy smartphone with a high uptime, or the lightweight smartphone with a low uptime? So QFD is with its own house of quality can show you the interactions between those features and show the quality risks that can come up from insufficient understanding of the end user's requirements by the owner of the product. Here, I will try to explain it why. So house of quality is the complex structure. It's complex structure, and you should live with this. So usually books can show you these pictures and explain like you can do here, 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 but see, like for me, it took several weeks to understand how does it work in real by only certain books. So I'll provide you the short example that will show you how does it work in real. So this house of quality will gather customer requirements on the level on the left side. Then it can also gather technical requirements that should correspond with the requirement itself, getting the priority, specific targets, have both customer assessment and technical assessment, and comes up to reveal those risks and trade-offs. You probably didn't understand anything from website right now. It's okay. Let's have a look. So just imagine you're creating your own, you're designing your own car, right? You want to create your own car. So what would you consider, what will be your customer requirements? What wants the market? What the market wants? Wants car should be fast, right? So number one is fast. Then how many gas it spends, right? So how many liters or gallons per miles, kilometers? It should be safe or not. It should be big, maybe, to have a place. It should be reliable, and it should be cheap, okay? You can see here lots of requirements that may contradict each other, correct? Like how the car with all these requirements might be cheap. It's impossible. But the good thing you need to know is to understand which of those requirements have the more weight coefficient comparing to cheap. Okay. The next, you would like to put the importance of each of those right here. So fast importance is 3 or 5. Let's say your customer doesn't care about the how many liters it spends per kilometer, so it will be 2, but it should be safe. It should be 4. It should be completely big. Your market love big cars, so should be 5. Reliable, well, a little bit more than the average, so it will be 3 and 5. And cheap, of course, our market would like to have a cheap cars. So you have to calculate the weight coefficient of any of those right here. So 3 or 5, like all together, we have 1, 2, 3, 4, 5, 6 requirements. 6, each of those will have maximum 5 points. So 6 multiplied by 5 will be 30. 30 is maximum point. So you calculate over here. Then you're thinking about the technical parameters. So what's the technical parameters of this? It might be weight of a car, right? It can be what kind of engine, what will be the production cost of a particular car, what is the expected life, it may be 10 years, 12 years, 15 years, 5 years, what will be the size of a car, and it will be, for example, like how many time it will take to speed up from 0 to 100. Okay, so there will be the 6 technical parameters. So now we'll be trying to align technical parameters with the customer requirements. So what are we going to do? We have to put the correlation between the technical parameters and the customer requirements. So this triangle means the lower, the better. This means the higher, the better. So we can take a look here and say, okay, weight. The lower is weight, the better, right? Right. Who needs heavy cars? Because they will be probably not cheap, and we have much more liters per 100 kilometers, etc. Engine. The better engine, the higher, the better. Okay. Production cost, the lower, the better. Expected life, the higher, the better. Size, the higher, the better. Okay. Acceleration, the higher, the better. Okay, we already have it here. Then we need to establish the correlation between the technical parameters inside. For example, compare weight with each of those. Weight with engine, weight with production cost, weight with expected life, weight with size, etc. So we have 4 types of correlation. Strongly positive means like weight and engine, they are related to each other, but not strong, right? For example, the engine and the acceleration have a strong positive correlation, right? So the bigger the engine, the better the acceleration. There are also strongly negative right here. So the bigger the size, the smaller the acceleration. That's correct. Strongly negative correlation. And see, empty points here means they do not correlate directly, like weight and production cost. They do not correlate. Then you need to define the relationships between technical parameters and the customer requirements. So you would think weight with fast, weight with liters per 100 kilometer, weight with safe, weight with big, etc., and establish each of those here. And now you will have to apply certain coefficients to each of those technical parameters right here. So if we multiply it, we have the importance of some technical parameters here. Then we also would create the benchmark. Our car with some different cars. There will be the Ford Expedition, Hummer E2, and Toyota Tundra, right? So we have here the parameters with these cars and own cars. So totally having all of this information, we could gather the risk of each area here to find something important. Like, for example, our design states, right, that fast, it will be very fast. Your close competitors are not so fast as your car, right? So you're like 2 points above them. But here on your gas spending, you're lower than they are. So you're getting here more, losing here a little. So take into account those correlations. You can establish the trade-off between your technical parameters inside and your customer requirements. And you can come up with the most effective solution with the smallest risk possible, then with a rich amount of competitors, you would still be able to sell your cars, right? So this is exactly what the most product designers are going through to understand will it be beneficial to sell this product on market or no, because we can create the perfect car, right, with 5, 5, 5, 5, 5 here, but nobody will buy it because there is the risk that people want this, don't want this. And doing all this will help you to define the list of risks that should be mitigated. And at some point, you will realize that this is work for you or not. So you can change your design, you can change your plans before you start to implement it. I know it's kind of complex, but still it requires some time for you to understand also. So when you'll be reviewing these slides, if you want, you'll have to go through each of these points here and think about why it's there and why it's there. All the formulas, all the calculations are here on this slide. So I put everything on here so it will be clear for you. I know we're 1 minute after the 3 hours. Sorry, I'm a little late. I will explain one more technique and we're done here. Okay. So the last technique here is the fault tree analysis. This technique is all about figure out the entire fault tree to understand what risks, what reasons of certain risks, why those risks are happening. So we'll try to understand why certain risks are happening. Simple example. Yeah, it's here. So simple example here is car hits an object, right? This is a risk. What should be the main reasons of this risk? There are two things. Driver doesn't see the object, right? Okay, yeah. And here should be, okay, sorry. That should be like this. So driver doesn't see the object, or driver see the object but still hits. So why driver can not see the object? Because object is around the corner, hitting somewhere. Driver might be drunk and driver might be asleep. So how to deal with all these root causes? If object is around the corner, we need to create probably more parktronics, more cameras on car, so vehicle can track it. If in case driver is drunk, we can create some device that verifies if driver is sober. So then allow him to turn the engine on, and maybe we can put some eye tracking device that will track if driver will be falling asleep, and put in some signal with light to wake him up, right? So in other case, Driver might see the object, but still hits. Why? Because car is going too fast. We can put some limits there. And it can be weak brakes. We can think about making the brakes more, better. And also we can think about how we can improve this other way. So basically what I'm saying, here's the risk. Car hits an object. If we remove all the underlying reasons, we can remove the risk, right? So if we can think what the reasons of the risk, we can remove those reasons and we can remove the risk itself. If you want to test it by yourself, you can free to go with the practice with a practice exercise. Just imagine if you went out to camping and you figure out that your flashlight is not turning on. Why it can happen? Your battery can be down. Your electronics can be wet. Your lamp might be broken, etc. So you can think about the reasons, and then you might think about the ways how to deal with those reasons. For example, if there is a risk that the battery will go discharged, and you want that your camping flashlight will work always, you can just create the way to charge it manually, right? To use some piezoelectronic device to charge the battery or something else, right? So this is another way. So this is the way of removal of the risk by detecting the underlying reasons. Okay, this is all that I have for today. Hope it was not only complex, but also interesting for you. And I still have time for the questions. You can also ask it right now. For those who don't have any questions, you're free to leave. It was nice to see you all. At least we're online, but still. Yes, so thank you for your time. Now I will continue to answer the questions. So if you don't have a questions, you can leave. Thank you. Okay, Vyacheslav has a question. So Igor has a question. Do you consider using the risk-based testing approach in a parallel with regular testing approach? If yes, that will be the approximate increase of testing efforts based on your experience. Okay, so based on my experience, I usually try to understand what customer expecting from the project. So if this project is, so if customer expecting like certain level of quality and saying, okay, we need to test it at very good level. So I always propose to customer the risk-based approach because it dramatically increases the quality of testing itself, because there are always gaps between the requirements. And even if you create regular functional tests, you will still miss the gaps between those test cases. So I would always recommend that if customer have can afford it. And what % of testing efforts will it take? I would say about from 10 to 20%. I'll say, I'll put it this way. So if it's a full cycle product with saying like a full Scrum team, saying like 7 people, I would assume it will take 10%. If this is a large set with like 5 Scrum teams, complex project, I would say like 20% of test effort. So it will be kind of that, but I usually offer both classic test approach and risk-based strategy, because usually it helps a lot to reduce the general risk, and customer eventually sees the benefit of it. Okay, the next questions is, what metrics do you collect for risk assessment? What metrics you mean? You mean the quality metrics, the risk metrics, or what exactly? I mean like it's not the characteristics, right? It's like you mean metrics to calculate the return on investment? This is what you mean? Hold on. Okay, I mean quality metrics. Okay, so not completely understand. Okay, so what do I do for gathering the metrics for risk assessment? Okay, to the quality metrics of a product by risks. Not completely understand the question. Sorry. I can just mainly assume. Can you provide an example? What do you mean the quality metrics of a risk assessment? Just provide an example, and I'll get it, I guess. So, because there are lots of different metrics related with the risk assessment. For example, if you want to provide the customer with the return on investment on this, you might also calculate how many defects were found by the risk-based test cases. And you can say, okay, without risk-based testing, those defects wouldn't be found, and they all would be found by maybe reported by end users, at least the bigger part of it, right? So from the other side, it will be also I would collect some quality metrics to see how risk-based testing improves the product quality itself. So in this case, I'll put it this way. I measure the quality of a product by the amount of features working properly. So when I found the defects by risk-based, I can put it to the different topic as you know, as the regular tests are being executed. Like a percent of the high priority bugs, etc. Just about your experience. Okay. Percentages of high priority bugs. Okay. I just don't know how to correlate this question with the risk assessment, because risk assessment is a phase. So it's a phase, and within this phase, it's not required to collect any quality metrics. So from what I said, what usually I create, what metrics do I usually gather? It's like, okay, usually I get the number of defects by components. I usually gather the dynamics of defects per component per release. So one release, certain percent of defects were here. In next release, there are more percent of defects in this component. So I have some opinion here. I can also track. I could track the amount of defect reported by end users per component, so I can clearly see if the priority were correct or not, and what are the gaps in testing, what defects were escaped. But eventually, it's very dependent on the project. Usually, people require just very lightweight metrics to capturing, because we'll know that if we need to plan the proper measuring, we need to start it from the very beginning, even on the planning phase, to implement those metrics with a good level of quality. Because here's the thing: if you want to build the solid metric set, you need to be confident in the source of metrics, right? Let's say you want to gather the defects by components. So you want to know how many defects was in this component, this component. This metric worth nothing if half of your team doesn't fill the field in the defect. For example, some of people will just leave this field blank, right? So this metric worth nothing until all the defects have filled, data in this field. So you know what I mean, right? So according to my experience, I use the very basic metrics that help customer to see the progress. Because to build more solid metrics, I would need to change a lot. I would need to change everything. I will need to make sure everybody is filling all the required fields to have a reliable metric. Because otherwise, if I would just apply all metrics I know, it can provide a wrong picture. Okay, next thing. What is your attitude to anomalies? What do you mean about anomalies? Do you have an experience or any feedbacks from others about implementing this approach in projects? About this, the main challenges and risks in the implementation process. Yes, I have such feedbacks from others. So the main challenges is to gather proper stakeholders. It's one of them. Some people just don't believe it and they don't want to participate in it. Another challenge is to get an agreement on the risk characteristics. Without a good moderator, it may went completely bad. And the last important challenge is to maintain these risks regularly. So you need a so-called risk management committee that will gather once a month, let's say, and review all the risks all again to see which of those were decreased and which of those are not. Okay, question from Igor. Do you think it's worthily reasonable to apply a risk-based approach in case of absence of competitors? Yes, if you would like to create a good, decent product at the very beginning. So you don't want to do a lot of rework in future. You want to get a good reputation and to get a good clients. Of course, if you can afford it. So I think the answer is yes. Sometimes it's needed, but if your desire is just to release something on market as soon as possible to cover the niche, then you might not consider this technique. Question from Anton: how do you implement risk-based testing into the project which is already in development and there were multiple releases? So here I would start from very simple risk management techniques from the SST. So just gathering the list of risks. Like, for example, it may be high-level risks. It may be, I would just maybe put some, okay, I would use the retrospective technique just to put the risks that are usually been happening over and over. That I'll put some risk from the defects reported by end users. So I'll create the set of like 10 to 20 basic risks that are legit, and I would start work from them, and then over and over by adding more and more, just to show people that this works. So people will also believe in this approach, because sometimes if you will just start full cycle approach with everything, people just say, oh, I don't believe it. I don't want to I don't want to participate in it, I don't have a time to play in your games, right? So sometimes it's very important to show people that these have a good potential, and this helps to detect defects. So I would start from this, and then growing more and more techniques. Okay, the question from Oksana is about the anomalies. Okay, there's something completely unexpected. Yes, some risks you even cannot predict. Like my neighbor who who was doing repairment at 8 p.m., right? So it's sometimes you cannot explain what's happening. Sometimes you even can't predict it. It's okay completely. But in future, you will still be able to predict that if it happened to you before. So once you face something weird, you can reuse this knowledge in future. But of course, we cannot predict everything. And this is the reality we're live in. So I would say, yeah, those anomalies, they do exist, but we cannot do much with them. Okay, any other questions so far? Okay, if no questions, then thank you for your time. Hope you're doing well. And here are my contacts, LinkedIn, Facebook. So please go ahead, add me there, and we can just talk more if you want, if you have any questions. So yeah, here you go. There are any chance for some minutes on how to do SST, that example you showed. We won't fit to 5 to 7 minutes. Sorry to that. What I can advise is just to do it by yourself, following the thing I was explained here, and you will get much more than from this video. So Anton, I would advise you just to review it back and try to do it by yourself. I promise you with like a 90% probability that you will get how to do it, right? So that could be it. Oh, and yeah, I'm kind of tired, so so I don't have any powers anymore to do some complex things. Anyway, thank you very much for your time. Have a good evening, or day. Thank you and good luck. See you another time. Thanks. Bye.